Hello students, now we will learn about force in this video. You all know force is an act of push or a pull which changes or tends to change the state of rest or of uniform motion of a body. For example, if I have an object here which is free to move, it is not fixed at any of the points, I apply a force on this body will go in a straight line. Now, what is the force doing here? It is producing a linear motion or translatory motion here. What if I fix one of the points like this and then apply a force on the other side? Now, will it go on a linear path? No, it is going to rotate. That means force can produce two types of motion in a body. The two types of motions are translatory or linear motion when the body is free to move, and when you apply a force on the body will go in a straight line. The next type of motion which a force can produce is rotatory or rotational motion. When you apply a force on a body which is fixed at a point, the body starts rotating about the fixed point. Rotating about the fixed point means this point is fixed. Now this body will start rotating around this fixed point. This is known as rotating about the fixed point, and the name of this fixed point about which the body will rotate is called pivot. Hence, pivot is the fixed point about which a body rotates. For example, you may all have come across this phenomena in your day-to-day life. When you open or close a door, you know the hinges which is at the corner of the door. Those hinges do not rotate. They are fixed at their point, and the hinges for the door, it is called the pivot. Now, we will go to a new term for you, that is called moment of force, or simply we call it moment, or sometimes we call it as torque. So what is this moment of force or moment or torque? It is nothing but the turning effect of a force about the fixed point which is called pivot. This turning effect is called the moment of force. Now when a body rotates, it may rotate in two ways. It may undergo a clockwise motion, and if the force has a tendency to turn a body in clockwise direction, the moment of force is called clockwise moment. If I turn this is the body which is rotating, this is the pivot. I apply a force in the upward direction. You can see it is rotating in the direction in which the clock rotates. This type of moment is called clockwise moment. Similarly, if I fix the other point and I apply a force in the upward direction from here, this type of motion, this type of moment is called anti-clockwise moment, because it is rotating in a direction opposite to the direction of the clock's rotation. Or if you want to fix this point only and you want to produce anti-clockwise moment here, what will you do? For clockwise, you just push it from the downwards direction. It will undergo clockwise moment, but if I just push it downwards, you can see it rotates just in the opposite manner. So you can change clockwise moment into anti-clockwise moment by just changing the direction of force. Now, let's move on to find out the factors affecting the moment of force. You know, to turn a body, you need to apply a force. Say, this point is pivoted here. You're applying a force. Unless you apply a force, the body will not rotate. So, one of the factors which affects the moment of force is the amount of force you're applying. That is called magnitude of the force applied. So, one factor is the force applied. And the second factor is the distance from the pivot to the line of action of force, which is in short called the momentum. This is the pivot, this is the line of action of force. I am applying the forces, so this entire line becomes the line of action of force. This perpendicular distance is called the moment arm. Longer the moment arm, more will be the turning effect. For example, I want to turn it from here. It is not that easy to turn. If you want to open the door from near the hinges, it is not that easy. That's why the handle is made towards the end of the door. That is to increase the moment arm. So more the moment arm, more will be the turning effect. So we have two factors here which decides the amount of moment of force produced. The two factors, you can see it here. One is the force and the second one is the moment arm. Compiling these two, we can get the formula for moment of force, which is simply the multiplication of force and the momentum. In short, I can write it as M is equal to F into D. This is the formula for moment of force. And talking about the units, SI unit of moment of force, from the formula, you know, unit of force is Newton, unit of distance is meter. Multiplying these two, you will get the SI unit of moment of force as Nm, which is Newton meter. Let's use the formula to solve a numerical here. Look at the question. The hinge, I told you what a hinge is. It is the pivot about which the door rotates. Of a door is 1 meter from the handle. That means you have a handle here, the hinge is here. The distance between the pivot and the point of application of force, which is the handle, is 1 meter. So this is our D. And a force of 70 Newton, the value of the force is given to be 7070 Newton. Now the question has asked you to calculate the moment of force. Okay, so put a question mark here, and in the next step you put the formula M is equal to F into D. Replace the values from the given data, 70 into 1 Newton meter, and the value of moment of force for you will be 70 Newton meter. Thank you.